Hello everyone, and welcome back to the Fluctus channel. Whether used for commercial or military purposes, large ships are extremely maintenance intensive. And while they can often enter dry dock in order to undergo heavy repairs or cleaning, many situations must be dealt with while the ship is still at sea. This includes removing various pollutants from the ship's hull, the propeller, and parts of the engine. This is not only a difficult process, but can also be a dangerous one. Nonetheless, allowing corrosion and buildup to advance can lead to reduced thrust, shaft damage, and diminished fuel efficiency. When talking about a ship the size of an aircraft carrier or container ship, this can amount to hundreds of thousands of dollars in increased costs. There are a number of companies that offer propeller and hull cleaning services. These organizations employ divers who use a variety of tools, mostly specialized underwater grinders, that can remove buildup while also polishing the propeller itself. When dealing with some of the largest ships in the world, it's not uncommon to encounter propellers that are 27 feet in diameter and weigh more than 100 tons. For this reason, it can take hours for a team of divers to finish polishing the blades, shafts, and hub. However, in order to ensure peak performance, this process needs to be repeated regularly. In some estimates, cleaning should be done every 3 to 6 months. As challenging as this sort of cleaning can be, it is mostly done at regularly shallow depths. In saturation diving, men and women regularly operate at depths of several hundred feet. In some cases, saturation divers have reached depths of over 2,300 feet, far deeper than anyone ever imagined a human could go. One of the most extreme forms of diving, the term saturation, refers to the process of bringing all tissues into equilibrium with the partial pressures of the breathing gas being used. It is often used in commercial diving to perform explorations for the oil and gas industry, to aid in recovery or salvage operations, and for scientific and research purposes. Before each dive, the divers will live in a specialized pressure chamber for up to 28 days. Here they breathe a mixture of helium and oxygen to prepare themselves for operation at extreme depths. They then transfer into a bell, which takes them down to the job. All of this preparation allows them to operate for just 6 hours before returning back to the chamber again. Once the job is complete, the divers must decompress for 2 days for every 100 feet of depth. Divers also play an extremely important role in militaries around the world. Though they may perform many different duties, the most common diving professionals found aboard are underwater construction teams, or UCT divers. These men and women undergo extensive training, not just focused on diving, but on building and repairing underwater structures and vehicles. In some instances, they may even participate in explosive hazard disposal. Due to the sheer fact of having to operate underwater, nearly every single mission will present its challenges and hazards. From welding to concrete repair to demolition, Seabees, as they're called in the U.S. Navy, must be prepared for virtually anything. There's a lot of international cooperation when it comes to naval diving. It's not uncommon for the U.S. to work with various allies worldwide. From completing training exercises to performing actual missions, like this salvage operation in the Black Sea. Of course, communication is important, which is why both teams will have their own land-based coordinators. Fortunately, diving uses several universal hand signals for communication. This eliminates many language barriers the international teams might encounter during the operation. Anytime that you have personnel underwater, be they divers or submarine crew, you risk the possibility of something going wrong. This has led to the development of organizations like the Undersea Rescue Command. This team of engineers and emergency personnel have access to all special equipment, including a pod known as the Submarine Rescue Chamber. This submersible can dive into the water and initiate contact with the hatch of a submarine or other underwater vessel. Once attached, it can bring emergency supplies or personnel on board, or retrieve injured or trapped individuals from below. The SRC is fully pressurized and boasts a maximum diving depth of 850 feet. NATO has a similar submersible rescue system, codenamed the NSRS. The chamber was designed by engineers from France, Norway, and the United Kingdom. The result was the world's largest flyaway transfer under a pressure system. A fully controllable submersible, it can reach depths of up to 900 feet. And rescue around a dozen trapped or injured submariners at a time. The submersible itself consists of 3 separate parts: a rescue vehicle, an intervention system, and a transfer under pressure system. Like the SRC, it can mate with the submarine hatch, allowing personnel to move back and forth as needed. Perhaps most impressive of all is the fact that the NSRS can be deployed more or less anywhere in the world in just 72 hours. It can also dive up to 6 hours at a time, as many as 4 times a day. Often referred to as the force behind the fleet, the Mid-Atlantic Regional Maintenance Center provides a variety of engineering and technical services to ships and subs in the U.S. fleet. Among these are propeller inspections and other services focused on ship operability and efficiency. This is often referred to as ship husbandry and includes everything related to general maintenance, cleaning, and upkeep of a military vessel and its equipment. Last but not least, MARMC teams frequently participate in submarine rescue and diving training. Regardless of the methods or vehicles used, it's important to understand just how risky a submarine rescue can be for everyone involved. Here, the United States Navy's Deep Submergence Unit is practicing a submarine rescue scenario with members of the Chilean Navy. The vessel being used is the CS Carrera, a 217-foot-long submarine with a complement of around 31 crew members. The rescue team is using a pressurized rescue module, similar to the SRC. While small, it is capable of holding nearly a dozen individuals and their equipment. Upon making contact with the submarine, the crew inside the rescue module can form a seal around the submarine hatch. They can then use a series of pumps to remove the water from the space between the two vessels. Once this is completed, they can open the submersible's hatch and deploy a ladder into the space.
Hatch is open!
At this point, the hatch of the submarine can be opened, thus creating a vertical bridge through which people, equipment, and virtually anything else can pass.
That way nobody eats it coming down.
Once the crew members are on board, the hatching process is reversed. First, the submarine hatch is closed. Then the chamber is flooded to prevent damage during uncoupling. Finally, the submersible hatch is closed and sealed, allowing both rescuers and rescued to make their way back to the deployment vessel. Once on board the large ship, the hatch can be safely opened and the rescue individuals can depart on the deck.
Here's your bag, sir.
There are certain situations where people on board a submarine may need to evacuate before a vehicle like the NSRS minisub can be called in. In this case, the crew can use a special technique in which they partially fill up the submarine with water and don special orange escape suits. They can then evacuate by way of the vertical missile tubes. This procedure is most effective when the sub is not in deep water, as this minimizes the risk of injuries like embolisms from the change in pressure. However, if medical crews are standing by to provide immediate support, crews can use the suits to remain partially pressurized as they rush toward the surface. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.